So while this question doesn't specifically ask us to do a two-way table, it makes a lot of sense because there's a lot going on here. So let's definitely go ahead and organize everything. So I started out by putting up a table here, and I'm going to go ahead and organize what we are given here so we can actually just go ahead and proceed from there. So it says 49 of the 100 students are girls. Well, first of all, it's 100 students, so I'm going to put in 100 here for the total. Okay. And 49 of them are girls. So total number of girls, 49. Okay, so 10 of them came by car. So I'm going to put a 10 in there. 16 boys walked. So I have 16 boys up here. And let's see, 21 of the 41 students who came by bicycle are boys. So that means that total number of bike people is going to be 41. And there are 21 boys that were in that category. Okay, so now that we have all this, we can go ahead and fill in all the missing pieces. So it's up to you how you want to do that, but I know that this is going on a binary boy-girl breakup for gender here. So we're looking at 49, and so that means that there's 51 boys over here. We can look at adding up the column for boys, so 16 plus 21. And if you add that together and subtract from 51, you're going to end up with 14 right here, which means that the total number of car people is going to be 24. And let's see, so that means that the total for the column, the number of people that walk total is going to be 35, so that column adds up to be 100. And then we can go ahead and fill in each of those two rows for walking and biking. So it means that there are 19 girls that walked and 20 girls that biked to school. So now that you have that, it makes these a lot easier to answer. So what's the total number of students who walked to school? So the total number walked right up top here at 35, so 35. Okay. What percentage of students who came by car were girls? So that means of the people that were came by car, so of the 24 people, how many of them were girls? So in this case, we can see that out of the 24 people that came by car, that means that we have 10 that were going to be girls. So it's a 10 there, which is approximately 41.67%. Okay, let's go out to two decimal places. So it says, would a Venn diagram be a good choice to represent this scenario? Explain. It's not really a good choice in this case because you have multiple venues, or essentially walk, bike, and ride, or ways they could have gotten to school. And those things are mutually exclusive. So you can't walk and bike and ride a car at the same time. That doesn't really make sense here. So Venn diagrams lend themselves nicely to situations where you do have some kind of overlap. But it's not exclusive to that. So it wouldn't be a good choice for this case right here. So I'll leave that blank there and you can fill it in with that. So the last question says, if a student is randomly selected, is it more likely that that person is female given that she rides a bicycle? Okay, so first of all, for that part, the person is female given that she rides bicycle. So the given part is the group that we're restricted to. So given that she rides a bicycle, so of the people that ride a bicycle, there are 41 of those. We're talking about that she is female. So if the person is female and rides a bike, that means that we're looking at 20 of the 41 people. Okay, and that comes out to be approximately 48.78%. Okay, so that's for the first one. Okay, so that's this one, given that she's a female. The other option is that it's a person rides a bicycle given that she's female. So given that the person is female, so out of all of the girls here, so out of all girls, there's 49 of those. We're looking for the number of them that rode a bike, so that's 20 of the 49. So that means that comes out to be approximately 40.81%. Okay, so this is the more likely option because it's a higher percentage. Okay, hope that helped.